Hello everyone and welcome to my channel. Today we will talk about numeric data types in Go, including integers, decimals and complex numbers. We will see how to declare variables of these types, perform arithmetic operations, compare them and convert between them. So let's get started. What are numeric data types? Numeric data types in programming are data types that represent numeric values. We have three numeric data types in Go: integers, floating point, and complex numbers. Integers represent a whole number, while floating point represents a number with a decimal point, and complex numbers are numbers that have both real and imaginary parts. Download the PDF from GitHub page to check all built-in numeric data types in Go and their range values. The link will be in the description. Let's see some examples for each of them. We can declare variable x to be 5. We will let our compiler infer the type for us. That way we can see what the default data type is. Next, let's print the value of x using the println function. To see the default type of x, we will use reflect package and its type of method. The reflect package offers runtime introspection, which is the ability to access and interact with values of arbitrary types at runtime. Each value in Go has two attributes: its actual value and its type. The reflect type of function can tell us about the type of any value. We can use a zero function to check what is the zero value for a particular type. Let's use the zero function to see the zero value of type int. When we run the program, we can see that value of x is 5. Then, using reflect type of function for variable x, we can see that the default type is int. The zero value for int is 0. If you want to learn more about reflect package, I will leave the link to the documentation in the description. Next, we will declare a variable y to be 7.85. And again, we will check its value, default type and zero value. When we run the program, we can see that value of y is 7.85, the default type is float 64, and the zero value is 0. Next, we need to use built-in complex function to declare complex numbers. The complex function accepts two arguments. First is a real part and the second one is an imaginary part, and both are of floating point type. Also, we can declare complex numbers using the initialization syntax that we can see for our z2 variable. We can see that the default type is complex 128 and the zero value is 0 for both real and imaginary parts. If we want to extract real and imaginary parts, we can use built-in functions real and imag. Here, when we run the program, we can see that real part is 2 and imaginary part is 5. Let's declare variable a with a type of int 8 and assign 200 to it. If we know that the maximal value for int 8 is 127, what do you think will happen if we run the program now? We will get an overflow error because we tried to initialize a number with a value that's too big for the type we are using. To fix this, I will change the value to 127 and let's add a 1 to it. What do you think will happen now? Let's print the variable a and see. It's minus 128? Yes, in this case the number wraparound. That means the number goes from its highest to its smallest possible value. And the smallest value for int 8 is minus 128. Note here, wraparound can be easily missed during development and later cause bugs for our users. Let's see what operations we can perform on our numeric data types. We already saw that we could use addition. Besides this, we can use subtraction, multiplication, division, and remainder. In these examples here, we can see arithmetic operations in action. Note here, remainder operator is only available for integers. Let's run the program and see the results. For all numeric data types, we can use comparison operators. Using comparison operators, we can compare two values of the same type. We will declare two integers, i1 and i2, to be 20 and 25. And we will check if i1 is greater than, less than, greater than or equal to, and less than or equal to i2. Also, we will declare two complex values and check for equality. Let's run the program and see the results. We can see that complex numbers are not equal. Both real and imaginary parts must be equal for complex numbers to be equal. In Go, all numeric data types are different, so we cannot use an arithmetic operation or a comparison of numeric values of different types. If we declare the variable a to be 25 and the variable b to be 4.23 and try to add a to b, we will get an error. Invalid operation, a plus b, mismatched type int and float 64. From my previous video, we know that int has a different size depending on CPU architecture, 32 or 64 bits. On my machine, int will have a size of int 64 if we declare a to be 25 and b of type int 64 to be 7. Even if they have the same size, they are still not the same type, and we cannot use them to perform arithmetic or comparison operations. The reason is that creators wanted to avoid portability issues. We will still get the same error as before. Suppose we want to do arithmetic operations or a comparison. We need to convert one value into another, and it's straightforward to do in Go. We use the syntax type, open parentheses, value, close parentheses to do the conversion. We can successfully transform from one type of number to another, but we must be careful. We can lose some data. Here are some examples. We already saw this example where we wanted to add int and float 64 together. So to do that, we need to convert either a to float 64 or b to int. Let's first convert int into float 64. To do that, type float 64 and in signed parentheses put a. Now, when we run the program, we can see that value of c is 29.23. Okay, let's see what will happen when we convert float 64 into an int. When we run the program, we can see that value of c is 29. Go will truncate the decimal part when we convert from a float to an int. One note here is that converting from a larger type like int 64 into a smaller type like int 8 will cause the number to overflow. In summary, we saw how to use integers, floating point, and complex numbers. We should always use the int type to declare integers unless we have a specific reason to use a size or unsigned integer type. Also, we know when the overflow error is happening and what a wraparound is. We explained how to declare complex numbers using the complex function and initialization syntax. We saw the default values for all numeric types and how to check for types in Golang using the reflect package. Download a PDF for this lesson with a code. Check link to the GitHub repository in the description. I hope you enjoyed this video. Until the next time, bye!